Hi everybody. In this video, we're going to talk about how we can tell if a system of equations has one solution, an infinite number of solutions, or zero solutions. Remember, a system of equations is just a bunch of equations. It could be more than two equations, but we're just going to talk about having two equations at a time like we've been doing in the rest of these videos. And we're also going to be talking about linear equations. So when we graph those equations, we always get straight lines. We're only talking about linear equations in these videos. All right. So when a system of equations is graphed, if the lines intersect once, the system has one solution. So I didn't actually give you the equations of these graphs, but imagine that you had a couple of equations here and the linear equations. So when you graphed one of the equations, you got a straight line like this. And when you graphed the other equation, you got a straight line like this. You can see that these lines intersect one time right over here. Okay, and that point of intersection would be the solution to the system. That is these values, so this value for x and this value for y, would solve both of those equations. Remember, individually, each equation would have an infinite number of solutions. So any point along this line would be a solution to whatever equation it was that gave us this yellow line. And any point along this line would be a solution to whatever equation gave us this purple line. But only the point of intersection, since it's on both the yellow line and the purple line, would be a solution to both of those equations. So that would be the only solution to the system, meaning it's the only solution for both equations, okay? All right, so we get just one intersection there. With straight lines, we couldn't get two intersections or three intersections. We'll only get either one or an infinite number or zero. Okay, so when do we get one intersection? This happens when the slopes are different. Very simple. If the slopes of the lines are different, then we will get one intersection. So for example, this purple line has a negative slope, and this yellow line has a positive slope. So even without knowing if it's, +3 or -2, even without knowing the specific numbers, if one of them is negative and the other one is positive, then they have to be different. So, so these slopes are different, and you can see that they intersect at one point. So we'll get one intersection when the slopes are different, even if the y-intercepts are the same. So you can see, and by the way, just a reminder, slope just means how steep the line is. So this would be a relatively small positive slope. This would be a much larger positive slope. This would be a relatively small negative slope. And this would be a much steeper negative slope, okay? For this example over here, both of the slopes are positive. As we move from left to right, both of these lines are going up. But that doesn't mean that the slopes are the same. Clearly, this yellow line is steeper than the purple line, so this yellow line has a greater slope, okay? But really all that's important is that the slopes are different somehow. And we can see, since the slopes are different, these lines will intersect at one point, okay? And both of these lines happen to have the same y-intercept. If you look at where the purple line crosses the y-axis, it crosses it right over here. And if you look at where the yellow line crosses the y-axis, it also crosses it right over here at the point 0, -1. Okay, but that's okay. The only thing that having the same y-intercept means is that that is the point of intersection. So over here, the y-intercepts were different. The y-intercepts were different, okay? And the lines just met somewhere else, okay? They intersected right over here. If the y-intercepts are the same, all that means is that the point of intersection is the y-intercept. Okay, but still, it's just one intersection. So there would only be one solution for that system of equations. Now, moving on, if the lines overlap, the system has infinite solutions. So there are an infinite number of x and y pairs that solve both equations. So for example, over here, since both of these lines overlap, really they're the same line. Okay, I made one of these, I made the yellow line thicker, but that's just so you could see it behind the purple line. But really these lines are exactly the same. The yellow and the purple lines are exactly the same. And what that means is I can pick any point along the purple line, and it is also a point on the yellow line. Or vice versa, I could pick any point on the yellow line, and voila, it is also on the purple line. So that means that any point that I pick along here, not only is it a solution to whatever equation gave us the yellow line, it is also a solution to whatever equation gave us the purple line. Okay, so if the lines overlap, if they're really the same line, then we have an infinite number of solutions. Okay, these, not only these two, but this and this and this and so on. Okay. All right, so moving along. Well, so this happens when the equations are exactly the same. Oh, I talked about that. Okay, good. All right, so moving along now. If the lines are parallel but don't overlap, so these lines over here are parallel, okay? They're moving in the same direction, right? And they overlapped. These lines over here are also parallel. They're also moving in the same direction, but they don't overlap. Okay, so if the lines are parallel but don't overlap, the system has no solutions. So for example, this point over here would be a solution to whatever equation gave us the purple line. And this point over here, okay, so this is a solution to whatever equation gave us the purple line, but it is not a solution to whatever equation gave us the yellow line, because it's on the purple line, but not the yellow one. Okay, and just to give you another example, this point over here is on the yellow line, so that would be a solution to whatever equation it was that gave us the yellow line, but it would not be a solution to the equation that gave us the purple line. Okay, so even though there are an infinite number of solutions to the equation that gave us the purple line, and there are also an infinite number of solutions to the equation that gave us the yellow line, there is no solution to both of those equations. Okay, none of these points are common to both of the lines, and that means there's no solution that is a solution to both equations, and therefore there's no solution to the system, because the system just means both equations. All right, so when does this happen? When do we get zero solutions? We know that it's when the lines are parallel but they don't overlap, but we can also say that this happens when the slopes are the same but the y-intercepts are different. So the slope just means how steep the line is, right? Both of these lines have exactly the same steepness. So both of these lines have the same slope, okay, which makes them parallel. But you can see here that the y-intercepts are different. This would be the y-intercept for the purple line. This would be the y-intercept for the yellow line. If those are different, then the lines are going to, if the y-intercepts are different but the slopes are the same, then the lines are going to be parallel but they're not going to overlap. So we're going to have zero common points and therefore zero solutions to the system. Whereas over here, the slopes were the same and also the y-intercepts were the same. Okay, this is the y-intercept for both the purple line and the yellow line. Okay, everything is the same about these lines. They're the same lines. All right, so moving along here, let's look at some examples with actual equations. All right, so here I wrote a couple of equations. So this would be a system of equations. right? Two equations, and this is going to be our system of equations for the first example. This system of equations has one solution. Okay, how do I know that? I know that very simply because remember, the number that is next to x tells us what the slope is. The coefficient that's in front of the x tells us what the slope is. So here I can see that the slope for this equation is 4, whereas the slope for this equation, remember, if you don't see a coefficient, then it is 1. So the slope of this equation is 1. Since those slopes are different, regardless of whether the y-intercepts are the same or different, if those slopes are different, then I know that the equation is only going to intersect once, and therefore there is one solution to the system. So if I were to just sketch these very quickly, if this is my x-axis and this is my y-axis, for this equation here, the y-intercept would be at 0, 3. Let's just say that that's right over here. And the slope would be 4. Okay, so let's just say that that it looks something like that, having a slope of 4. Okay, we could do it as 4 over 1, so we could go up 4 spaces and then over 1 space to find the next point, right? So we'll get something like that, just as our quick sketch. Okay, and what about for this one over here? The y-intercept would be at 0, negative 2. Let's say that that's somewhere around there. And the slope would be 1. So that looks something, it's not as steep as this one. It's still positive. So it's, as we go from left to right, it's still moving up, but it's just not as steep. So maybe something like that. Okay, and we can see that these lines intersected in exactly one place. That's going to happen anytime that the slopes are different, regardless of whether the y-intercepts are the same or not. In this case, the y-intercepts were not the same, but it doesn't matter. If the slopes are different, then we're going to see just one intersection there. All right, what about this other example over here? This one is very similar to the first one. In fact, this equation is exactly the same, so I don't have to change this line over here, but this one, what am I doing? Let's put that back. Okay, there was my y-intercept of 0, 3. Okay, and this equation also has a y-intercept at 0, 3. The constant term is 3, okay, which tells me that the y-intercept is also 0, 3, except here, once again, the slope is 1, which is not the same as over here where the slope was 4. So this one is not going to be as steep. And you can see that when I sketch that line there, again, these two lines intersect in only one place, so there would only be one solution to the system. Okay, it just happens to be that since the y-intercepts were the same, the solution to the system was exactly at the y-intercept. Okay, but the important point is that they only intersect once, so there's only one solution to that system. Now let's move on a little bit more and look at, what about this example over here? This one will have an infinite number of solutions. I keep doing that. All right, this one will have an infinite number of solutions. Let me draw them in different colors. Okay, so here the constant term is 5. Let's say that's over here. And the slope is negative 2. All right, so that, well, let's say that looks something like this. Okay, so that's that line. This line over here also has the constant term, the term that does not have an x next to it, is also positive 5. So that one, the y-intercept would also be right over here. And the number next to x is, well, we have a minus 2 over here. So that slope is also going to be negative 2. So really, these lines are exactly the same, which means that any point along here is a solution not only to this equation, but also to this equation, because really it's the same equation. Instead of writing negative 2x plus 5, I wrote 5 minus 2x, but really that's the same thing. So this All right, this will have an infinite number of solutions to the system. Okay, everything that is a solution to the pink line, which was given to us by this equation, is also a solution to this equation given, which is represented by the blue line here. Anything that solves one of them also solves the other. So this one has an infinite number of solutions. And let's look at this example here, 0 solutions. Let's see why that happens. Again, doing that. Again, we're going to get no solutions when the slopes are the same, but the y-intercepts are different. We can see here the number that is next to x for both of these is 4. Okay, and the constant terms are different. That means the y-intercepts are going to be different. So the slopes are going to be the same. Both lines are going to have the same steepness, but they're going to cross the y-axis at different places. So this one over here, which is actually exactly the same as this equation, has a y-intercept of 0, 3, and then the slope is 4. So let's do a quick sketch of that. This one over here has a y-intercept of 0, negative 2, okay, and the slope is also 4. So this one will have exactly the same steepness as the other line, which means that they're parallel. So if the y-intercepts are different and the lines are parallel, then they're never going to intersect. They're never going to cross each other. Okay, we could keep extending these forever and they're never going to meet, either in this direction or down here in this direction. And that means that whatever is a solution to this equation will not be a solution to this one, and whatever is a solution to this equation will not be a solution to this one. Again, I know I've said this a bunch of times already in this video and in the other videos, but just because the solution doesn't have any solutions, it doesn't mean that each individual equation doesn't have any solutions. Both of these equations have an infinite number of solutions. Anything that's along this line is a solution to this equation, and anything that's along this line is a solution to this equation, but there are no solutions which solve both of these equations. All right, and we can see that from the graph because the lines are parallel and they have different y-intercepts, so they're just not overlapping, right? Okay, and now let's continue. This is sort of similar to what we did before, but here I gave you all the slopes, all of the equations were already in nice slope-intercept form. Now, what if I give you some equations which are not already in slope-intercept form? Well, all you're going to do is you're going to solve for y. You want to get the y alone, and then you'll be able to tell if the slopes are the same or different, if the y-intercepts are the same or different, and you'll be able to use these rules then and easily tell if the equations have 0 solutions, or an infinite number of solutions, or one solution. Okay, so let's get these y's alone here. So, oopsie daisy. I forget to write an equal sign in here. Okay, so there's my equal sign. All right, so let's get the y alone. So right now, this 48 is on the same side. So what I can do here is I can plus 48, I can subtract 48 from both sides. I can't subtract it from this term because this has an x and this doesn't. What I can do is I can put it off to the side here, and then that cancels. I get negative 48 plus 40x equals negative 8y. And now to get rid of that negative 8, I have to divide by negative 8, which means I'll have to divide both of these terms also by negative 8. So this cancels. I get y equals negative 48 divided by negative 8 is positive 6. And positive 40 divided by negative 8 would be negative 5. So I would get minus 5, and this one has the x. So minus 5x over there. So that's my equation. That's equation A, but in slope-intercept form now. So I can see easily that the slope is negative 5, and the y-intercept would be at 0, 6. Now let's solve this one for y. So let's see, what do I want to do over here? I want to get this x term away from the y term. I want to get it on the other side of the equal sign. So it's not on the same side as y. So I can subtract 1/5 x from both sides. This does not have an x next to it, so I'm going to have to, I can't really combine this with this. So I'm going to get y over 25 equals 2 minus 1/5 x. And then to get rid of this 25 here, this is y divided by 25. So I'm going to have to multiply this by 25 and then multiply this by 25 also. So these cancel over here and we get y equals, and then let's see, 25 times 2, that's not hard. So that's just 50. And then 25 times, let's do this, negative 1/5 times 25. We'll put the 25 over 1. And then we have a negative times a positive is negative. So let's just keep that negative right over there. And then 1 times 25 is 25. 5 times 1 is 5. And then 25 divided by 5 is 5. Okay, so I'm going to get negative 5 here. So this is going to be minus 5x. Okay, so what do I have here now? I can see that the slopes for both of these equations, if I were to graph them, then the slopes would be the same. So the steepnesses of those lines would be the same. They would both be negative, so they would both be pointing down, but they would be exactly as steep. Each line would be exactly as steep as the other, but the y-intercepts here are different. So if I were to sketch this real quickly, I would see that here the y-intercept would be at 6. So let's say maybe something like that, and then slope is negative 5. Here the y-intercept is at 0,50, and the slope again is negative 5. So the y-intercepts are different, but the slopes are the same, which means these lines are parallel. They're not overlapping. They will never intersect. So this system of equations would have 0 solutions. Again, if the lines are parallel but don't overlap, the system has no solutions. This happens when the slopes are the same, but the y-intercepts are different. All right, let's move on to the next example here. All right, so again, we're just going to solve for y. Remember, it's the equal sign that separates the two sides of the equation, and we want to get everything away from y. So the only thing that's on the same side as y in this equation is that minus 27 there. So that's not too hard. We'll just add 27 over here and then also on the other side. Okay, and then this is just going to give me positive, I don't have to write that plus sign in front really. So 27 and then plus, this was a positive, so I'll just put a plus sign over here. That was a positive 12. So plus 12x equals y. Okay, so that one was pretty easy. I already got the y by itself. I can see that the slope is 12 because that's the number that's next to x. The y-intercept would be 0.27. And then over here, again, this one's not too hard. To get rid of this 6 over here, that's the only thing that's on the same side as y. All this other stuff is already on the other side of the equal sign. So the only thing that we have to do to get y by itself is to multiply this by 6, and then we'll do the same thing on the other side, multiply all this stuff by 6. So here the 6's cancel, and we get y equals, then we have 6 times 2x is going to give us 12x. And 6 times 4, everything is positive here, so that makes it easy. 6 times 4.5 is going to be 27. So we're going to get plus 27 over here. So we can see that both of these equations really are exactly the same. I have them written a little bit differently here, but we can see that for both of them, we have y equals 12x plus 27, which is the same thing as 27 plus 12x. Okay, so it's the same in both of these, which means that the y-intercept is the same and the slope is the same. Everything is the same. It's really the same equation here and here. Okay, which means that whatever solves this equation must also solve this equation. Okay, if I were to find an x and y value that makes both sides over here the same, then if I plug that same x and y value into here, it would also make this the same because really it's just the same equation. Right? So this would have an infinite number of solutions. This happens when the equations are exactly the same, okay? And if we were to graph them, since they're exactly the same, they would be right on top of each other. Same y-intercept, same slope. All right, let's just move on to the next. So that was an infinite number of solutions there. Okay, let's move on to the next example over here. Now you might be looking at this equation over here and thinking, wait a minute, isn't that exactly the same as the equation that we just did before? I did that on purpose, just to make a point that you have to really pay attention to where the equal sign is. Okay, here we have y over 6 equals 2x plus 4.5. Here we have y over 6 plus 2x equals 4.5. Okay, the equal sign is not in the same place. So that means that for this equation, not only am I going to have to get that 6 away from the y, because I want to get the y by itself, I'm also going to have to get this plus 2x away from, get the plus 2x away from the y. All right, so I can do that. That's addition. The inverse is subtraction. I can subtract 2x from both sides. This does not have an x in it, so that's going to give me y over 6 equals 4.5 minus 2x. And now I can go ahead and multiply both sides by 6 to get rid of that. Okay, so I'm going to, remember, whenever I divide or multiply, I have to do it to every single term. That's why I put both of these terms in parentheses here. So both of them get multiplied by the 6. So that's going to give me over here y equals, and then this is, we did this already, right? So that's going to be 27. And the only thing that's different here is now I have a minus sign here. So this is going to be minus 12x. And now let's solve this one. So let's see, I'm going to have to get rid of the negative 81 and also the 3, and then the y will be alone. So it's always easier, I feel, to get rid of this term first as opposed to the term which is right next to y. So to get rid of this term, this negative 81, I can treat this like a minus sign, even though technically it's a negative. And then the inverse of that would be addition. So I'll add 81 to both sides. Okay, so I'm going to get, if this were a minus sign, I would have to copy it. I don't have to bother with a plus sign. So 3y equals 81 minus 12x. This line is just to show you that's where the equal sign is, but I'm just going to erase that because to me it looks kind of messy. But it is good to draw a line if sometimes you forget which side is which, just to make sure that you're doing things on both sides, etc. Okay, so now it's time to divide both sides by 3. Now you might be looking at this and thinking to yourself, the slopes here are the same, but they're not the same because really we're not done over here. The y still has a 3 next to it. So we have to divide that 3 away. This is 3 times y, so we have to divide that 3 away. So let's divide the other side as well. And then we're going to get y equals 81 divided by 3 is 27. Okay, and then this minus 12x divided by 3 will get minus 4x. All right, now we can see over here that the slopes are different, even though the y-intercepts are the same. The y-intercepts, if we were to graph these, the y-intercepts for both of them would be at 0, 27 on the graph. Okay, but the slopes are different. So if the slopes are remember, if the slopes are different, even if the y-intercepts are the same, then the lines are going to intersect once. We're only going to have one solution. Okay, so if I were to sketch this quickly, the y-intercept here would be at 0, 27, and then the slope is negative 12. So that's going to be a really steep slope, but in the negative direction. So maybe something like this. Okay, and we'll say that this is 0.27 over here. Okay, here the y-intercept would also be at 0.27. So it's the same y-intercept, but here the slope is -4. So that slope is not going to be it's still going to be in the negative direction, but it's not going to be quite as steep. So I don't know, maybe something like this. Okay, so the fact that the y-intercepts were the same here, all that means is that the intersection is at the y-intercept, but it's still just one intersection. There's only one point where those two lines meet. We're never going to get 2 intersections or 4 intersections or 10 intersections. We could get an infinite number of intersections, but it's never going to be exactly 2 or exactly 3. It's going to be either 1 or 0 or an infinite number of intersections, which means also solutions. In this case, it's just the one intersection, which means the one solution. So this is a solution to this equation if we were to plug the x and the y values in here, and it's also a solution to this equation. All right? So this one has one solution. Thank you for watching, and have a great day.